Hello and welcome to TN Academy. For today's question, we have a diagram that shows a park that's viewed from above, and we have the distance between 2 points A and B. Now, it's actually, they're not playing baseball, but football. And we're given the fact that Odette is playing football in this park, standing at point O, such that OA is such and such meters, and we're given an angle. For question 1, we're asked to calculate the area of triangle AOB. So, one equation that we will need for this question is that the following, that H should be, I believe here, H is equal to a sine theta. Okay, so and we know that area is equal to 1/2 base times height, and so if we substitute our values into this equation, we get area equals 1/2. We have our base, 9 meters, and our height, which we find or calculate using our equation, is 5. Okay, and then if we compute our values, we find that area is equal to 67.47000. So we can round this. We can round our answer to be 67.5 meters, meters squared. Okay, and now for our next question. Question B, we're asked to calculate Kemal's distance from B. Where Kemal is Odette's friend, and he's standing at point K, such that he is 12 meters from A, and KAB is 45 degrees. So we were given these two values. Now, to calculate Kemal's distance, we can use a cosine rule, where, this is question A. For B, we'll use cosine rule, where C is equal to square root of A squared plus B squared minus 2AB cos theta. Okay. So when we plug our values, 12 squared plus 6.36 squared is 2. Six cos of 45 degrees. Okay, so using the cosine rule, we can find the distance between K and B. And when we substitute and compute all of these values here, we find that the distance from K to B is about 8.74 738 meters. So we can approximate this to just be 8.75 meters. And that's our answer to question B. Now, for our next question, moving on, we're given a few more facts. So that XY is the path of a semicircular path with the center A. And that KAY is 45 degrees. And the path and Odette's football. Kemal is standing on the path and Odette's football, so the football is at point X. And it's all shown in this diagram, of course. And we're given another side length, an additional angle, an additional two angles, in fact, which is angle KOX. KOX, I think that's this angle here. And OKX. Okay. So that'll be there. And here. 51.1 degrees. Okay, so for our next question, we're asked to find whether Odette or Kemal is closer to the ball. Okay, now, so for this question, we don't know the angle, this angle here, I believe, but to find the distance, we can use the law of sines. We're going to use ratios. Okay. So we have the following given information as well that I've listed it all out just to make it a bit easier for us. We know that Kemal is 22.2 meters from the ball, and we know these two angles. So now we can compare the sides using the law of sines, where OX, which is Odette's distance from the ball, we can compare with the sine of 51.1 because it directly opposes the side, of course, and that's how sine law works. And we can compare that with the 22-meter side and the sine of 53.8. And then if we rearrange this equation by multiplying both sides by sine of by multiplying both sides by sine of 51.1, we can isolate for OX, and after computing that, we should find that OX is just equal to 21.4099 meters, which we just approximate to be 21.4 meters. And of course, we know that Kemal's side length, or Kemal's distance from the ball, is 22.2 meters. And so that means that Odette is in fact closer to the ball. And the question, and that answers our question, question C. Now for our final question, we're asked to calculate the distance Kemal runs. I believe, yeah, the distance he will run if he runs circularly to the ball. And this question is a question about arc length. So we have to use the formula for arc length. Okay, and the formula is that arc length, I'll call it arc L, is equal to 2 pi r multiplied by our angle theta over 360. And 2. So we can calculate this angle here, as it's not given, by taking 180 minus 45, which should be 135. Okay, so, and that will be our theta. So if we substitute all our values into the equation for arc length, we get 2 pi, radius 12, multiplied by 135 divided by 360. And then after we compute our values, we get the arc length of 28.2743 meters, which we just can round again to 3 significant digits, which is 28.3 meters. And that is our answer to question D, which is the distance that Kemmel will run to the ball. And that is all for these questions.